Thank you for the time, Mr. Moderator. Let me present our research entitled Preliminary Studies on Thermal Performance of Thermosiphon Solar Water Heating System. My name is Putu Wijaya Sunu, represent our colleagues, and we are from Bali State Polytechnic. Okay, let's continue with Indonesian government commitment in the energy sector. Our government released peraturan pemerintah number 79 in 2014 about kebijakan energi nasional and strengthened with peraturan pemerintah number 22 in 2017 about Rencana Umum Energi Nasional. From this legal document, we can see the energy demand for domestic application from 2015 until 2050 with various kind of energy, and this various kind of energy dominated by electrical energy and consume mostly the electrical energy for air conditioning and water heating. So this is our challenges as a researcher in application of renewable energy for energy conservation and sustainability in domestic system. Because our government uh, push the utilization of renewable energy. Uh, in this slide, we are focused in solar water heater. This compact solar water heater application for space heating, domestic hot water, and pool and others. In our research, we use a thermosiphon system. The thermosiphon system depend on the different between the different density between hot water and cold water. Water flow, the cycle is created in the two. Hot water flow automatically upward while the cold water flow down. The water in the compact solar water heaters storage tank will be heated from this natural circulation. Next, we see our experimental setup. In this investigation, a typically laboratory scale of flat plate solar water heater manufactured in Denpasar City. And this is our test rig. The specification of this solar water heater system you can see in this table. First, the solar collector aperture area about 1 meter square. Collector protection material is single glass, 5 millimeter thickness. Collector channel copper tube, 0.25 inch, and collector slope 15 degree until 45 degree. And this is as a variable, independent variable in this results. And in the upper side, in this side, the thermal storage tank, orient, horizontal orientation, and 60 liters volume. And the data, all the data measured digitally using solar power meters and K-type uh, thermocouple. And the data collected from all sensing temperature every 10 seconds for 12 hours. 12 hours. Okay. Let's continue with result and discussion section. The solar water heater was connected with thermal storage tanks on a horizontal frame about 3 meters above the ground, and it oriented north at Denpasar city. And all of the data collected from June to July 2020 on a sunny day. Let's start with the figure in the upper left side. This figure is time series of the average solar radiation. Generally, the maximum solar radiation was recorded around 13 to 14 on a bright day. It's seen that the solar radiation of 25-degree solar collector reached the maximum value compared to others. Let's continue with the upper right figure. This figure shows the average ambient temperature. This figure has a similar trend with solar radiation. The ambient temperature has a strong correlation with meteorological circumstance. The data talking from June to July 2020, and the climate in Denpasar city is tropical dry season. The clearness of the sky is high, and the temperature ambient in this experiment period, June to July, was the lowest throughout the years. Let's continue with the bottom left figure. This figure shows the delta T, delta temperature of solar collector. The temperature difference between outlet and inlet collector for 40-degree tilt have the highest value in this graph. The 14-degree tilt solar collector have the lowest inlet temperature, but in the other hand, in this tilt has the highest outlet water temperature. And so the temperature difference, the delta T between outlet and inlet collector for 40-degree tilt have the highest value. And the next figure is the graph about average thermal storage temperature. Uh, it's as justified in the previous figure. For glass cover temperature, the 40-degree tilt solar collector have the modest value, and the thermal performance of the thermosiphon solar water heater may indicate by the outlet and inlet temperature difference. This phenomenon proved in this figure. We can see in this figure the maximum thermal storage tank temperature reached by the 14-degree tilt solar collector. Okay, the next section is our conclusion. A flat plate thermosiphon water solar water heater equipped with a horizontal storage tank has been investigated in 5 different tilt angles. Water temperature was digitalized during solar collection on the day period. For the optimum tilt angle 40 degree gave the best result, 22 degrees Celsius in temperature difference between outlet and inlet solar collector in this experiment. And the total heat absorbed by a 14-degree tilt angle solar collector was about 5,520 kilojoule. Okay, this is all our presentation, and hope you can join in question and answer session. You can give me an input to improve our research for the future. Thank you very much, and I give the time for the moderator. Thank you.